Assalamualaikum students. As you all know that we were studying chapter number 9, refraction and dispersion of light. So today the topic of our lecture is total internal reflection. So students, what is total internal reflection? You can say the complete reflection of a light ray reaching an interface with a less dense medium when the angle of incidence exceeds the critical angle. Now here the question arises, or you can also say okay, when light rays strike the boundary of a transparent medium, the rays are reflected inside the denser medium. So here the question arises that what is critical angle? The critical angle is the angle of incidence at which the reflected ray just gets out of the block or 90 degree and most of the rays reflected. You can say the critical angle is the angle of incidence in an optically denser medium for which the angle of refraction is 90 degree. Now there are some conditions you can say, or some conditions are there for total internal reflection light. The light must be traveling from a more dense medium into a less dense medium, that is glass to air. Glass to air is just an example. The angle of incidence must be greater than the critical angle. And now I have already told you what is critical angle. Coming towards the next topic, that is using total internal reflections. Glass prisms can act like perfect mirrors. If light rays strike an inside face at an angle greater than its critical angle, a ray shown strikes the glass boundary at 90 degree angle, enters the prism unrefracted. When it moves on to strike the inclined side of the prism, the angle of incidence will be 45 degree, which is greater than the critical angle of glass. Total internal reflection will take place and the ray is refracted at an angle of 45 degree, making it strike the second glass boundary. Now, what are optical fibers? Optical fiber is a technology associated with data transmission using light pulses traveling along with the long fiber, which is usually made of plastic or glass. Now, why is this important in total internal reflection? Because they are bundled together and used as light bulb. So optical light hits the sides of the fibers at an angle greater than the critical angle. All the light is reflected and it emerges from the other end of the fibers almost as bright as when it went in. Another application of total internal reflection is periscope. The periscope uses total internal reflection inside triangular prisms. Some cameras also use prisms for capturing images of objects on film. A periscope is made up of a tube at the end of which two mirrors or prisms are fitted at 45 degree but parallel to each other. A periscope is used in submarines, ships and war trenches for marksmen to see their surroundings without being seen themselves. Another one is mirage. Mirage is an optical phenomenon that creates the illusion of water, often with inverted reflections of distant objects. Fish and other aquatic animals and divers see a reflected view of the objects present in their surroundings. When light reflects from the outer world to the boundary of two different media such as air and water, total internal reflection occurs. As a result, objects move above the surface such as the moon, plants and sun are visible to the fish under the water. However, the shape and distance of the image of such objects are different from their real frame. So students, that is it for today's lecture. In the next lecture, we will study dispersion of light. Thank you so much.